Hello friends, this is Jim with Science Talk, and I have an update involving Thwaites Glacier in Antarctica, and the news is alarming. So here's the headline: Giant void hidden under Antarctica's ice threatens the vast glacier. So, as it turns out, underneath the massive ice sheets, there's a void. And this void is growing larger, and it's becoming more threatening to the overall stability of the rest of the glaciers. And how do they determine that there's this void? Satellite data. So, this is a report that was published in the journal Science Advances. One of the co-researchers, Eric Rignol, who is a professor of Earth Science, Systems Science at the University of California, Irvine. He's also principal scientist for the Radar Science and Engineering section at NASA's JPL in Pasadena, Jet Propulsion Laboratory. Now, Dr. Rignol, you might have remember I have mentioned him before in other video segments. He does quite a bit of work on Antarctica's ice. So, what is going on? This cavity is large, quite large. To put it in perspective, it's about 2/3 the area of Manhattan Island. And it is nearly 1,000 feet or 300 meters in height. It is growing at the bottom of Thwaites Glacier in West Antarctica, and it is rapidly enabling ice melt above it. Now, previously scientists did think there might be some gaps between Thwaites Glacier and the bedrock below it. And why is this a problem? Well, if you have some gaps there, some ocean water, liquid form, could infiltrate, and it being warmer, could start melting from underneath. So you can have this water flow in, and then you have, it starts melting the glacier that sits above it. But the surprise is the immensity of this void and the speed at which it is growing. That is the kicker. Now, how large is this void? It is thought to have held 15 billion, with a B, tons, which is 13.6 billion metric tons of ice. Much of that ice has melted during the last 3 years. That's according to NASA, satellite data. So Professor Rignol basically says we have suspected for years that Thwaites was not tightly attached to the bedrock beneath it. And using satellite data, scientists were able to spot this concealed void as a new generation of satellites. Like everything else, technology improves, and this enables us to get more information. These satellites are part of NASA's Operation Icebridge and have ice-penetrating radar. The researchers also use data from a myriad of Italian and German spacecraft that are equipped with SAR, which is synthetic aperture radar, very widely used type of satellite to gain information of the Earth's surface below. And in this case here, they're looking at how the ground surface, they're measuring how the ground surface has shifted between images. These tools revealed that the ground had shifted substantially from 1992 to 2017. That's what these researchers found. The size of a cavity under a glacier plays an important role in melting. This is a quote from the lead researcher, Pietro Milillo, a scientist at the Radar Science and Engineering section at JPL, basically a direct colleague of Professor Rignol. As more heat and water get under the glacier, it melts faster. So couple that with warming air, melting from above, now you got melting from underneath, and it's going to do this, right? Now, Thwaites Glacier is about the size of Florida. It's a big expanse and is currently responsible for about 4% of global sea rise. If the entire glacier melted, the resulting water could raise world ocean level by more than 2 feet, 65 centimeters, that's conservative, the researcher said. Moreover, the glacier acts as a backstop for neighboring glaciers, meaning that it slows the rate at which they lose ice. If those glaciers melted as well, sea levels could increase by 8 feet. That's not counting the glaciers on East Antarctica. All total, if you melt every single ice sheet, glacier, in Antarctica, Greenland, and so on, conservatively speaking, you're looking at probably about 25-meter sea level rise, depending on the estimates. And don't forget, there's also thermal expansion that needs to be factored in. So that would be basically drowning a lot of coastal regions, of course, obviously. So I just did a video segment where I discuss how the sea ice around Antarctica is dwindling rapidly, and the sea ice holds back any of the land glaciers. With the sea ice disappearing, the land glaciers, the land ice is basically going to be moving more quickly to the sea. Nothing holding it back, so they can push their way into the sea, break off. Currents take them into warmer water. That ice melts. Sea levels go up. Now, as I discussed with you folks before, Thwaites Glacier is a very difficult place to get to. The logistics is difficult, but the U.S. National Science Foundation and the British Natural Environmental Research Council are launching the International Thwaites Glacier Collaboration, which will be a 5-year field project in the field that wants to get as much information as possible, and they want to look at the glacier's processes, features, and get a handle on melt rates. You get the idea. Now, the interesting thing, and it really shouldn't come as a surprise, but Thwaites Glacier is not melting in a uniform manner. It kind of makes sense. The differing features of the bedrock, where the void is, uneven cooling, heating, that sort of stuff. So Professor Melillo basically states, we are discovering different mechanisms of retreat. For instance, the 160 kilometers glacier front has different rates of retreat in its grounding line. And you might recall I did a video segment some time ago where I described what the grounding line is, and it's basically where the sea ice meets the ocean bedrock, sea ice. So you got this is what I was just talking about before, the sea ice basically holding back the land ice. The satellites reveal that the enormous void is hiding under the glacier's western side, the one farther away from the West Antarctic Peninsula. In essence, this means that the glacier at this spot is exposed to the ebb and flow of the tide, which causes the ice at the grounding line to retreat and advance across a region that's about 3 to 5 kilometers in length. In other words, this can help accelerate loss of land ice into the ocean. There's been more retreat than advancement as of late. The glacier has retreated at a steady rate of about 0.6 to 0.8 kilometers annually since 1992. This has made the melt rate on this part of the glacier, to use the scientists, the researchers' own words, unsettlingly high. Couldn't get that out. Basically, they're extremely alarmed at what's going on. On the eastern side of the glacier, the grounding line retreat proceeds through small channels, maybe about a kilometer or so wide, sort of like fingers and tendrils reaching beneath the glacier, melted from below, as opposed to a big frontal assault, in essence. The retreat rate of the ground line, this is on the eastern side, has doubled from about 0.6 annually from 1992 to 2011 to 1.2 kilometers a year from 2011 to 2017. So starting about 8 years ago, it has kicked up its rate, it doubled it. Despite this high rate of retreat, the melt rates are still higher on the western side where the void is located. So basically, these findings indicate just how complex ice-ocean interactions are, and hoping that this upcoming collaboration will allow the researchers and scientists to gather more information, gather some critically important needed data, and look at the different systems that are at work under and around the glacier. Understanding the details of how the ocean melts away this glacier is essential to projecting its impact on sea level rise in the coming decades, Professor Rignall states. So, there you have it. A big void, which will allow oceanic water to infiltrate from underneath, increasing the rate at which the glacier melts, thereby adding more water to the ocean, elevating sea levels. So, as always, I will stay on top of this as the studies get published and keep you up to date on the latest findings. This is important. It may seem far away. It's down, down at the end of the planet and so on. Well, what happens in Antarctica does not stay in Antarctica, just like what happens in the Arctic does not stay in the Arctic. It will have ramifications for the entire planet. So, I thank you for your time, and we'll talk soon. Hey friends, this is Jim reminding you to subscribe and share my videos. Also, don't forget to click the bell so that you know when I drop a video in. And I'm also asking for you to please support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your continued support.